Shut up. Why are you getting started? You were so good before you came in here acting fool.
He wrote McGee like Joker.
I did not write that. He is lying.
All right. Just a recap for the video if you're going back to watch this, and I forgot to hit record. All we have said is that if two things multiply together to give you 0, then at least one of those two things must be 0.
We also said Mr. McGee like Joker.
All right. Now what we're going to do.
All right, and that's on the video. Everyone watching this video does not like to do it.
Wow, All right. First thing we're going to do, we're going to make our equation.
Interruption, but at this time, all senior.
First thing we're going to do is make the equation equal to 0. Okay, because the 0 product property does not work if the equation's not 0 first. Right, Mr. Deal? Right. Okay. So we make the equation equal 0. The second thing that we do is we factor everything. And then we set the factors equal to 0 and solve. So 3 steps, super easy. Can anyone tell me while y'all are writing this, if I'm looking at the graph, so I'm looking graphically at my quadratic, if I'm solving algebraically, what am I finding when I find those x values? Your x-intercepts, you're exactly right, good job. So do you understand why I get 2 answers? If it's the x-intercepts and I'm talking about a parabola, that's why I can get 2 answers, okay? Just so you remember. All right. Let's do an example, and then I got to show you a couple special patterns. Special patterns. Solve for x. Solve for x. So if I ask you to solve this for x, your first thought is probably, okay, well, can I stat map my way out of it? Have y'all heard stat map before? Backwards PEMDAS. Can I solve it? So if you only see x in there one time, I can solve it just like a linear equation, right? Can I get x by itself? And as you look at this, I obviously know I can't because it's a what? Quadratic, right? Any question that I ask it there right now, probably the answer. My quadratic or parabola would be the choice. Anyway. Linear. Okay, it's definitely not linear. Why is it not linear, Grayson? You don't know what linear means? Okay. If I'm going to solve the quadratic by factoring, I first need to make it equal 0. How do I make this equal 0? Add 9. How do you know, this is important, how do you know what to move where? But how do I know to move the 9 and not to move the 4x squared and the 12? It'd be harder. What would make it harder? The negatives. Who said it? The negatives. So look, I'm going to make this little note for you. Write this somewhere in your notes. Always move terms to keep the leading coefficient. What's a leading coefficient? Not before the x, but before, move. Always move terms it's going to make your factoring life easier. Okay? So as you decide what am I going to move where, I'm always going to move to keep my leading coefficient positive as I move. Okay? So that's why. I know it will, see, sometimes you'll have to move more to keep the leading coefficient positive, but it'll make it easier for you in the long run. All right. So I've got it equal to 0. I'm ready to factor. So my steps in factoring, run me through them. GCF, do I have a GCF here? No. So I'm ready to go ahead and start factoring, right? 4 times 9 is what? 36x squared. Give me two factors that multiply to 36x squared but add to 12x. 6x and 6x. Everybody okay there? Yep. What can you take out of the first two? What's left? Middle sign drops down. What can I take out of the last two? And what's left? Now what? What? Okay, cancel out or take out. So what's the factor that's coming out? And what's left? Oh. I still haven't solved. How am I going to solve? Set each one to 0. That's exactly right. Set each one to 0. I get the same thing, though, if I set those to 0, right? What do I get? How could I have a parabola that is giving me the same answer twice? The vertex falls on the x-axis. That's exactly right. Grayson, it's time for you to go. I might have to rip your homework out of here. I'm sorry. I'm not acknowledging it, Grayson. All right. This is a perfect example to lead us up to what else I want to talk about. I'm not going to spend a real long time. I'm not going to spend a real long time on solving this way because it's such an easy concept setting the parentheses equal to 0. Instead, I want to really use this time to focus on some factoring techniques and a couple special patterns that you're going to see. I guess we'll start with this since it's already here. There's just two that I want to talk about today. The first is called a perfect square binomial. Perfect square, tell me what that means. Two of the same number, multiplied by itself to give you that value, right? Give me some examples of perfect squares. Yes. 9, 16. Give me some variables in there. 81x squared, right? What times itself twice gives you 81x squared? 9x, okay? You see where we're going with this? All right, so that's what perfect square means. What's trinomial mean? 3 what? 3 nomials. 3 terms in my polynomial, right? 1, 2, 3, separated by pluses and minuses, yes? Right. All right, so here's what a perfect square trinomial is. three terms. The last sign is always a plus. That's the first criteria that you're looking for. Is the last sign a plus? The first sign could be a plus or minus, it doesn't matter. The next thing you're looking for is, are the ends of the trinomial perfect squares? So one, second sign is positive. Two, ends are perfect squares. And here's where it gets confusing. Have y'all seen perfect square trinomial before? Has anybody ever tried this? The middle of my trinomial, this is my third check, is it a perfect square trinomial, has to be, take the square roots of the ends, so A and B, multiply and double them. 2 times A times B. So it's double the product of the square root of the ends. And that sounds like a mouthful. I used to, whenever I taught Algebra 2, I'd stand up like an idiot dancing in front of the room telling them the square dance, where we go square, square, multiply, and double. Because it's the, what? No. Square root, multiplied, and double give you what's in the middle. Okay, so I'm going to show you some examples. But before I do, let me show you why this is handy. This is handy because if you want to fact, you recognize it being a perfect square trinomial. Then what all I have to do is do parentheses, do the square root of the first, whatever this first sign is, the square root of the last, and throw a squared on it, and it's factored. So I heard some of you, as you were working through your work on Friday, that some of the numbers were really big. You're like, oh my gosh, this is horrendous. And as you were working through, it actually was a perfect square trinomial, and it could have been done just like that. You hadn't seen that yet, and I wanted you to see that you could do it either way. So I'm going to show you a couple of those as well. Look back at the one we just did. We did it by hand. This is what we started with. Look at this, 4x squared plus 12x plus 9. Is that a perfect square trinomial? I hear no and I hear yes. Let's go through the checklist. Is the second sign a plus? Are the ends perfect squares? Yeah. What times itself twice gives you 4x squared? 2x and 2x. What times itself twice gives you 9? 3. The big question is, does it square dance? What's the square root of 4x? Or 4x squared. 2x, what's the square root of 9? If you multiply those together and then double it, do you get what's in the middle? Yes. So yes, this is a perfect square trinomial. Which means if I factor it, I don't have to multiply the ends together and find that special puzzle piece. I can just say, oh, well, I know that this is 2x plus 3 squared. Is that what we got when we factored it by grouping? Look back at that example. Yeah, it is. Let me give you a couple examples. You tell me yay or nay if it's a perfect square trinomial. Yeah. Say it again now. Yes, yes, yes. Yes or no, perfect square trinomial? Second sign a plus. Ends perfect squares. Does it square dance? Yes. X times 4 doubled. Factor it then if it's a perfect square trinomial. Close. Whatever the first sign is, that's the sign that's going to go inside. Minus. And so you might say, yeah, but Miss McGee, it's easier for me just to group it. And it might be. But what if I get to one? Perfect square trinomial or no?
I'm not sure.
Second sign of plus? Ends perfect squares. Does it square dance? Yes, it does. Square root of the first is what? Square root of the last one? 5 times 12 is? Doubled is? That what sits in the middle? Hold on, I'll go back to it. So it's 5x plus 12. Do you know how long you'd be here if you multiplied 25 times 144 and tried to find the two things that added to 120? Right? So it's a good shortcut for that. Now, Will, what'd you ask me? How did I do that? Because x times x and 4 times 4.
I did 8.
Wait. I hear no right off the bat. I hear yes. Second sign of plus? Ends perfect squares. Does it square dance? Why? I would need this to be 24 in order for it to square dance. Yay or nay? I hear yes. Everybody agree? Look at you, Finley. Almost tricked you. It's almost a perfect square trinomial, but this sign right here keeps it from being one. It does square dance. The ends are perfect squares, but the second sign's not a plus. This one's actually not even factorable. Yeah. All right, let me show you the last pattern. I'm almost done, I promise. I can tell you're getting restless. The last one is what we call a difference of two squares. I saved the easiest for last. I'd rather knock out the hardest one first, and then that's the hardest pattern, yeah. Difference means what? Subtraction, minus, that's exactly right. If I've got two perfect squares separated by a minus sign, to factor that, it's so easy. It's the square root of each one in parentheses. One goes to plus and one goes to minus. Okay? This is the one we had where you had to get a 0 in the middle. You know what I'm talking about? It had to multiply to whatever, but it had to add to 0. That's what this is. So, for example, Now, this does not work if there's a plus in the middle. Make yourself a note, whatever you need to do. It is not the sum of two squares. It is only when it's difference. Your key word here is difference. It's got to be subtraction. Okay? All right, so what do we say? We take the square root of this one, which is minus 9y, and then we do the same thing but with a plus. That's it. That's the answer. Now, for what we're going to be doing today also, remember these, we're talking about equations now. So we're going to make them equal 0, okay? We're going to try to factor, but our steps in factoring, we're going to kind of add another step in factoring now, in that whenever I factor, yes, I'm still going to look for GCF. But before I go on to my factoring steps, I also want to look for a special pattern. So I just want to kind of glance and go, okay, let me just make sure I don't have a perfect square trinomial or a different square. You might not like perfect square trinomials right now. They might be a little hard for you to remember. And right now, you can still group them and slash them and do it the way we've been doing. We will get to something at the end of this unit where you'll have to be able to recognize it. So I would recommend going ahead while it's kind of easy right now. Tell me what you think. Today's really a day that's pushed in here for us to practice with our factoring technique. Throwing these extra 2 on there and the solving is just a little something extra, but really we're practicing with those factoring techniques today. All right.